Okay, hi guys. Today we're going to talk about GMOs, but we're going to start out talking about dogs because first of all, this debate gets everybody all riled up, and talking about puppies definitely isn't going to hurt, and also because it's relevant. Okay, so a very long time ago, like more than 15,000 years ago in northern Eurasia, there were wolves and nomadic people. The nomadic people kind of wandered around hunting, gathering, and it's believed that the wolves probably trailed the people and then started to happily coexist with them, and slowly over time, people started to breed the best hunters together for a super hunter dog and the most docile for companion and later for physical features. Fast forward. Now we have pugs! So cute. They can't breathe on their own, but I mean, look at him in his sweater. It's so cute. Okay, let's try a different one. So corn, we know it, we love it. Popcorn, incredible stuff. You gotta try it. Anyway, so corn, as we know it now, is really amazingly different from ancient breeds of corn found 9,000 years ago. It was less of a corn and more of a wild grass thing called teosinte. It had a few kernels and a really tough casing, and its flavor was described as not particularly palatable. So it sounds amazing. But in the Balsas River Valley in south central Mexico, early farmers started to crossbreed for the best quality corn, and over time, corn was developed into what we eat today. So go with me here. GMO stands for Genetically Modified Organism, and that sounds really scary in labs and whatever, but really those two examples are genetically modified. We picked and chose our favorite genes and bred them together, and therefore modified the gene sequence going forward. Bananas don't look at all like OG bananas, and tomatoes are super different, and pretty much all of our food has gone through processes of crossbreeding or selective breeding to create plants that grow bigger and resist bugs and taste better and feed more people. So these kinds of genetic modification, like with crossbreeding plants, has been around for roughly a gazillion years. What hasn't been around for a gazillion years is genetic engineering. So this kind of started in the 70s, really got going in the 90s. Basically, genetic engineering is just a method that allows scientists to copy a gene with a desired trait from one organism and put it into another organism. If this sounds familiar at all, it's because it is. It's the same vibe as genetic modification through crossbreeding over time, except really sped up, a lot more exact, a little more science, probably some beakers and technology and stuff, I don't know. Right now, there are 10 foods that are approved for general consumption that are genetically engineered, all for different reasons or problems or solutions. You might be like, plants were good before, let's not put them in a lab and mess with them, let's let them be happy in the field. Fair enough. Story time. So we're gonna hop over to Hawaii. Hawaiian papayas are big business. They're the 5th largest export of the state. It's a $17 million industry and supporting tons of farmers and feeding lots of papaya lovers. Yay, cute! So starting as early as the 1950s, there was this little disease called ring spot, and it spread, and by 1997, the virus had basically destroyed the entire papaya industry. Ugh. But then in 1984, a team of scientists from Cornell and the University of Hawaii had started doing trials and experiments, and it took 7 years, then a few more years for FDA approval, but they created a papaya called the rainbow papaya, which is resistant to ring spot. And then they gave the seeds to all the farmers for free, and the papayas came back, and now they're big Hawaii business once again. So cute. So that's one of those 10. It's designed in a lab, genetically engineered to solve a problem, and declared safe for human consumption and for the environment. So this is great, except there's a pretty large and active anti-GMO movement, and as a person who came into this with just nothing to gain, and I didn't really know much, and what I learned is that the arguments against GMOs seem to be largely based around 3 things: environmental impacts, if they're safe for human consumption, and access to the use of seeds. Let's get into it! So let's start with, are they safe to eat and put in our bodies because important? So once upon a time, aka 2012, this guy named Gilles-Éric Seralini did a study with rats. Importantly, not a ton of rats, 10 in each group, which in science is not really enough, but anyway, he gave them all different diets. He fed some groups GMO corn, some non-GMO corn, and then some of them he just gave straight up Roundup, which is a weed killer, in their water, which is not how we drink. Anyway, so on the treated groups, or the GMO eating and Roundup drinking rats, Seralini found enormous tumors and claimed the treated rats died 2 to 3 times more than the controls and much more rapidly. So he wrapped up his study, announced a press conference with no scientists allowed, where he released the results of his study and also a book and a movie. Anyway, reverse! Okay, so let's get into it. Seralini's little rats were all over 2 years old, which is the lifespan of a Sprague-Dawley rat, and they have a really high likelihood, one study says an 80% chance, of developing cancer and tumors after the age of 2. So let's just play this experiment out on this little group of 10. If 8 developed cancer naturally, kind of hard to say which one would have developed a disease with or without GMOs. Also, Seralini refused to release photos of the control rats, which seems weird. Anyway, so basically scientists from every corner of the earth emerged to be like, hey, I don't know about how this study was done, and by November of 2013, the publishing journal retracted the Seralini study. However, the damage had already been done. The study got, and still gets, a ton of media attention, and literally was quoted in an anti-GMO podcast I listened to in preparation for this video, this week. So it made a big splash, despite being objectively sketchy. So the whole Seralini situation aside, are we good to eat GMOs? According to 280 global science organizations and literally 6,000 peer-reviewed studies done in the last 21 years, there is scientifically no proven danger to humans in eating genetically engineered food. Full stop, that's it. The general consensus is that each crop should continue to be tested individually before approval, but at the moment, no proven danger whatsoever. If you want to hop off the video now, I get it, but there will be more pugs. So let's hop back to the other couple of issues with them, the seed access thing from before. This is definitely debated, and there have been legal issues around the use of genetically engineered seeds. So for example, say you have a small farmer who isn't purchasing genetically engineered seeds, but borders a larger farm which does use genetically engineered seeds. So there's this natural process of cross-pollination, which goes across fence lines, and there have been lawsuits against those smaller farmers being sued for the quote-unquote use of the seeds, which is insane. The seed industry is largely consolidated and makes an enormous amount of money, so there needs to be allowances for cross-pollination across property lines, fair and equal access to these seeds, and the right to save seeds for farmers that do want to grow genetically modified crops. Okay, so now let's talk about the environment in GMOs. Mostly crops are genetically modified to either be pesticide or herbicide resistant, so farmers can spray pesticides and kill all the boll weevils or whatever, and they can spray herbicide on their crop and all the weeds and stuff will die and that plant will just be chilling unbothered. So one big argument against GMOs is that weeds will become resistant to the existing pesticides, so we'll have to scale up our pesticides in either volume or strength and toxicity. And if this sounds scary, I agree, this sounds scary. So again, these things have only really been around since the 90s commercially, so our research can only go back that far, but based on scientific evidence so far, see above, kind of a lot, genetically engineered crops have led to a decrease in the use of quality-adjusted pesticides. So this means even if in some areas the pounds of pesticide is increased, the toxicity has significantly decreased. I got into it, I read science, I googled words, I promise. But getting back to the super weed thing, so yes, when weeds become resistant to glyphosate or Roundup, we'll need to scale up herbicides so that it can kill the new super weeds. That's a bummer, but we're starting from a lower toxicity level than we would have been otherwise. In fact, greater biodiversity has been found in fields with GMO crops because there's less pesticide and herbicide use. There's a wider variety of things like ladybugs and other little bugs, cicadas maybe, I don't know, maybe not. So this whole issue is complicated, lots of sides, lots of opinions, but if you'll indulge me for a second, I also just want to say that I've been really inspired in my research by the potential that genetically modified crops have. For real. Really quick, in a ton of developing countries, mostly Africa and Southeast Asia, vitamin A deficiency is a very big issue. It causes preventable blindness, throat and chest infections, infertility, measles, chronic diarrhea, poor wound healing, a lot of really bad stuff, particularly in pregnant women and children. A lot of children, the World Health Organization believes 250 million preschool children are impacted by vitamin A deficiency. So in a ton of really impoverished countries, our household budgets allow for about a cup of rice a day. So scientists using genetic engineering inserted genes from daffodils, which contain beta-carotene, which creates vitamin A in our bodies, into rice, and thus created what is now known as golden rice, a portion of rice which contains between 80 and 100% of the average daily requirement of vitamin A. So according to some projections, it could save around 2.7 million children a year from dying really awful deaths of vitamin A deficiency related illnesses, but because of anti-GMO advocacy, it's been effectively kept out of the market and only approved by a few countries really recently, including the Philippines in 2019. But imagine if we keep testing things safely and making sure all systems go before bringing them to market, we could have bird flu resistant chickens and crops that are tolerant of rising temperatures and drought and feed a bunch of vegetables to a growing number of little earthlings and pugs and sweaters. So cute. I know this topic is spicy and divisive. I have all my sources listed. Please check them out and stay tuned for more videos and topics and puppies and happy little papayas. Thanks!